Everybody, it's Tyler here in Wisconsin at the FTC qualifier Green Bay Hackerz event. I'm here with 7974.
Great Scott!
This team is absolutely on fire so far. Already have an event win under the belt, currently number 1 seed as we're recording this. And this robot is all about simplicity and effectiveness here. You might have saw this team during Robot in 30 Hours. They've made some improvements since then. We'll talk about those claw improvements they've been making. You got to check out how their slides are working out. And some interesting things they do with their drive as well too. And we'll talk a little bit more about pathing through Roadrunner as well too. Let's learn more about this team coming up here on Behind the Bot. Benji, let's talk about the build philosophy on this robot. You guys have built such an awesome machine and a lot of simplistic things to it, so walk me through it.
Yeah, so our robot, one thing we wanted to do this year is make it really simple and really quick on the field. You'll notice our robot does not have a lot of moving parts and, complex functions. That's by design. We wanted this to be a very simple and easy to build robot so we could maximize driver practice and get on the field as quick as possible. And that's really paid off for us this year. We've already qualified for state, so we're doing great. And I think this is a very, simple robot that teams can all kind of strive to look at because it's really quick on the field and really easy to build. So if you're a rookie team that's looking for something that's easy and quick, this might be something like this that's something you're looking for. I'll pass it over to Brem.
All right, so I'm here to talk about our claw in specific. So during the Robot in 30 Hours competition, which is something where you get 30 hours at the beginning of the season, right when the challenge releases, we designed this claw. And we didn't like it at first, so what we decided to do is we decided to go with a pyramid shape instead to try to get more flexibility with the grip on the specimen thing. All right. But then we decided to go back to our original claw design because we didn't like how the specimen could move around when we were holding it.
Josh, you guys have been really fast in the field in terms of scoring those samples and those high baskets. So walk me through what your slides and elevator look like and why it's been working out so well for you.
Yeah, of course. So what we want to do is, of course, as mentioned, keep it simple, as little moving parts as possible. And what that means is that we have more time to focus on optimizing every single little part. So one of the first things that we did is we knew that compared to the arm that you probably saw during the Robot in 30 Hours, we decided that instead we wanted to have an extension linkage. Now this gives us actually more reach into the submersible and opens up a lot of possibilities for grabbing and intaking more samples. Another thing that we noticed though is that we can't keep the claw down all the time, so we added a pitch up. This has the double function of also being able to grab specimens off the wall and then score them very neatly on the rung. We also have our linear slides here, which are standard go-build Vipers driven by two 435 RPM Yellow Jacket motors. And they are stacked right against each other to improve the rigidity of the design. And then they are able to fully reach the high basket, low basket, high rung, anything that we need to score on.
How did you optimize some of your scoring cycles to get your time down so quickly?
Of course, it was a lot of driver practice, and then our driver's actually here, so I'll pass it over to him.
So a lot of how we've had so much success with such a simple robot is just driver practice. We have been on the field so many times. We have so much experience with driving this thing that it's just gotten quicker and quicker and quicker. If you watch footage of this competition versus footage of our last competition, with pretty much the same robot, our cycle times are way quicker. And we also work to optimize. We focus on specimen usually right now, and we work on grabbing them from the submersible as optimized as we can to limit lost time. So for example, if there's a robot blocking the path to the submersible, we'll just go somewhere else. But while we go somewhere else, we'll grab one from the observation zone and score it so we don't waste the precious seconds of going back to the observation zone and then going right by where we're scoring just to grab and not score. So it cuts down on a lot of time and allows us to get our cycle numbers up.
Let's take a look at this drivetrain here. Josh, when we were talking earlier, mentioned that you're running a half direct, half belt drive. So I'd love to see more about that and why you chose to go that route and how it's been working out for you.
Yeah, of course. This is another design that presented itself during the Robot in 30 Hours. And the idea basically came about because we wanted to have a really, really low center of gravity. With the amount of vertical extension that you need to have in this game going towards the high basket, your robot can become tippy very, very fast. So a lot of what we focused on was making sure the center of gravity is low. So we have all 4 of our drivetrain motors down here at the very bottom. Now, it was partially inspired by the parallel plate drivetrain design that we ran last year, Many teams also do with custom materials, but because it's made out of Gobilda, we just chose to direct drive the back wheels and belt drive the front wheels, which allows for a more simplified design and really speaks to that simple approach that we like to use.
So this is something you'd recommend for other teams to try out too?
I would certainly recommend it, yeah. It's worked really great for us. It's been extremely reliable, and it's very, very easy to maintain.
Let's start to wrap up and talk about what you're using for software, which is Roadrunner on here. So Jack, tell me more about how Roadrunner's been working out for you, maybe what some of your pathings look like.
Yeah, so we use Roadrunner for our autonomous pathing, and last year we used Roadrunner, but it was not tuned very well at all. So this year we really made sure to tune it and make sure we do the hard work before getting to the fun stuff, because when you do the hard work first, it's way more fun in the long run. So follow the tuning steps carefully, and because we've done that, we've had a way more consistent and easier to make autonomous, and we've been able to do a 4+0 with the samples, a 1+3, 1 specimen, 3 samples, and then we also have a 4 specimen auto. And while it's not the top of what's possible, we think that we'll be able to get there with some more practice and some more time while working with the autonomous.
Josh, last thing I want to ask you is future improvements. Any big plans and changes as you look forward to get ready for state?
Of course, yeah. We're looking at changing a lot of things, and we actually have another robot brewing in the background. We're looking to bring a lot of mechanical upgrades, lots of new software, and a lot of really cool things that you can look forward to.
Well, great, Scott. Good luck here, of course, the rest of the event, but we can't wait to see how you do at state, hopefully even beyond as well, too. So good luck the rest of the way, and thanks for telling us more about this awesome robot. A lot of great things that teams can learn from this. Good luck, guys.
Thank you so much.